Right, there we go. Okay, so we left off with a couple expanding problems still. Let's go through those and then we're gonna learn some calculator tricks. So if you don't have your calculator out and ready, go ahead and get that on deck because we're gonna need that for number 3. But before we do that, we gotta go back to letter E and F. We didn't finish those. Those were problems like 2A, B, C, and D where we were expanding. Remember, expanding means to like spread it apart. We're going to go from 1 log to 2 or 3 or however many logs it takes. The one thing that's funny about E is that it's a multiplying problem, but we kind of forget that it is. See how it's 100 times x squared? With that times, I'm allowed to separate this into 2 different logs. Remember, the multiply separates it into a plus, so I'm going to do log of 100 plus log of x squared. I'm going to go a step further though. If I have exponents, I want to bring it out front. I physically see an exponent on the x. However, can you write 100 as a number with an exponent? Can you write 100 as a number to an exponent? What'd you say, Ryan? 10 squared. So this is the same thing as 10 squared. So I'm going to bring that 2 out front as well. Bless you. 2 log 10 plus 2 log of x. All right, quick team timeout. Let's explore this log 10 for a second. If I pull him out for a second, just to kind of prove a point, log 10, if I had that in one of my log roll questions and said, hey, what if that equals x? What would that be if I log roll it? What's my base here? 10, okay. So 10, what would it be when I log roll it? Good, 10 to the x equals 10. So x equals 1, right? Log of 10, any log with the same base, like log of 2 of 2, log base 2 of 2, log base 5 of 5, anytime you have a log base and then you're doing the log of the same number, that cancels out to just be 1. So this log 10 is the same thing as 1. I'm going to say this is like 2 times 1, which is 2. So the log 10 essentially goes away and I get 2 times 2 log of x. I know there's a lot to kind of think of in these log problems, but I'm trying to point out kind of the easy ones. I think that's a pretty simple one to see. Log base 10 of 10 is the same thing as 1. We're going to see something super similar in the next one, okay? I've got another multiplying problem. So I'm going to separate that with a plus sign. So I'm going to say ln of 30 plus ln of e to the third. Can we write 30 as a number raised to an exponent? I can't think of one, can you? So I always ask myself that. Sometimes like 100 you can, sometimes like 30 you can't. So I can't on this one. So I'm going to just carry that law ln of 30 down. But I do have myself a little exponent here. Bless you. You're welcome. The 3 is going to come out front, so I'm going to do 3 ln e. Ooh, ln e. What's the base for ln?
Log e.
Log e. This is like log e of e. Is that similar to that log 10 of 10 we just did? What is ln of e the same thing as? 1. The base is e, and if we were to log roll that, it'd be e to the x equals e. That just makes it 1. So the most simple form of this is going to be ln of 30 plus 3. Quick question here. Can I add that 30 and that 3 together?
No.
Why not? Ava, you were quick with that. Why?
Because the 30 is with the ln, and then the 3 is, it wouldn't go with it as like a whole separate part. Like 30 there is not like just by itself, it's part of the ln.
Good.
And the 3 it does not have an ln in it.
Good. It's just not attached to it, right? So the 30 goes with the ln. It's like they're together, so I cannot separate them. I cannot add 30 plus 3 to get 33. So this is as good as it gets. That's how the function works. All right, that was all of our expanding. Are we doing okay with that? All right, now I'm gonna teach you some calculator stuff. So go ahead and get that calculator out. I'm gonna teach you a longer version and then I'm gonna teach you a shortcut. The reason I teach you the long version is some people don't have the shortcut on their calculator. So I wanna make sure everybody has access to the way of doing this. So I'm gonna do 3 the long way and then I'll do 3 the short way. All right, so when I have log base 3 of 4, you notice on your calculator, there's a button that says log, right?
Yeah.
If I hit that log though, that is assumed that it's log base 10. I can't make it have a base of 3 right there. A lot of people want to do like 3 and then they like raise it to the 4th. That is not the same thing as log base 3 of 4. So you cannot do that. If you hit this log button, it's implied that it's base 10. In order to be able to do this with a different base, I'm going to make a little fraction. I'm going to have a log on top and on bottom. And I'm going to separate the 3 and the 4. The number that is in the base goes in my denominator. So 3 was the base, so I'm going to do log of 3 in the denominator. 4 is what we're doing the log of. That is going to go in the numerator. So the one way that I can do this in the calculator, log base 3 of 4 becomes log of 4 divided by log of 3. So I'm going to say log of 4 and parentheses divided by log of 3 and parentheses. And I get 1 point. It says round to the 10,000th, which is 4 places. So I'm going to go 1.2619. That's not too crazy, is it? All right, let's do the next one. We're gonna do our fraction again. Log of what over log of what? Which one goes on top? Which one goes on bottom? 11 on top. And then what goes on bottom? 7. The base goes on the bottom. That's what I remember. Base goes on bottom and then the other number goes on top. So I'm going to say log of 7, or sorry, log of 11 divided by log of 7. All right, one more like this. How am I going to set this one up? 0.3 is on the bottom. Good. So I'm going to do log over log. It's going to be log of 0.3 on the bottom. And then what's going to go on top? The 17. Very good. Log 17 divided by log 0.3. Oh, too many points. And I get negative 2.3532. Now I know I called that like the longer version. That wasn't too crazy, was it? That's not too difficult. You can definitely do that. And in case you can't remember the shortcut, I wanted to do enough of those that you remembered. Log base on the bottom, log of what we're doing on the top, log of 17 over log of 0.3. Now, the shortcut. If you have a TI-83, then you probably can't do this, but you can still check. I want you to all press math, and I want you to scroll down on math until you get to the letter A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then A. My A says log base. Is that what yours says? Good, click it. Do you see now that you can enter a number in as your base and a number in as what you're doing of? So I'm going to do the very first one we did. So I'm going to say log base 3 of 4. I'm able to put the little subscript of the base and the normal number, and I'm going to get the exact same number that I got at the beginning. That's fancy. Again, some of you may not be able to do this, and that's okay. So again, I went to math, and I scrolled all the way down to the letter A. All right, why don't you try the next 3 in the column next to it, doing this method or the other method, doesn't matter to me. Anybody not see it and need help?
Billy, would you do it?
Okay, those are the answers I got. Does that look good to you guys? We doing okay so far? All right, not too bad yet, right? We're doing okay? Hanging in there?
I used to restroom.
Go for it.
Thank you.
Okay. All right. Okay, let's flip to the next side. You guys ready to go to the next side of our paper? All right. We're gonna do some word problems there, mostly just kind of plugging and chugging, and I will use my calculator on this, so I'm gonna leave it up. I'm just gonna make it a little bit smaller. Oh, I wanna make it a little smaller. Okay. All right, so these problems are both have log equations for us. The first one is talking about light intensity. So it says the relationship between intensity I of light in lumens, depth of x feet in Lake Superior is given by this equation. What is the intensity at a depth of 10 feet? What do I do to solve that?
Put 10 for the edge,
Why?
because it's x feet and you wanna find out when it's 10 feet.
Good, it says x feet and we wanna know when it's 10 feet, those go together. So I'm gonna plug in 10 for x. So log of I over 12 equals negative 0.0125 times 10. Right, and then we can just start plugging and chugging. I'm gonna get the right side like simplified a little bit. Negative 0.0125 times 10. Good, so I get log of I over 12 equals negative 0.125, bless you. Now from here, does anyone have any idea on what I should do? Can't do that yet because that's inside the log. Can we get rid of the log somehow?
Yeah, base 10.
Base 10? Then what? Good, roll that. 10 to the negative 1.25 equals I to the 12. Or I over 12, sorry if I said that wrong. 10 to the negative 0.125 equals I over 12. Can you do 10 to the negative 0.125 in the calculator? Why not? I don't know what it is, but we can do it. 10 caret negative 0.125, and I get 0.7499 equals I over 12. And then how do we get I all by itself? Multiply by 12. I'm gonna take that number times 12 and I get about 9. 9 is about what I is equal to. Oh, we're coming with a lot scarier. All we did was we plugged in and we did a log roll. That was easy. All right, can we move to the next one? The cool thing for the next one, we're just also gonna do some more plugging in. So this one's talking about the Richter scale. It says the Richter scale magnitude R of an earthquake is based on the features of the associated seismic wave and is measured by this equation, where A is the amplitude, T is the period, and B accounts for the weakening of the seismic wave due to the distance from the epicenter. We're gonna do a lot more with amplitude and periods and stuff when we get to sine and cosine. That's a lot of probably vocab words you're like, I've never heard that before. We're gonna get to it. But this is in the log section because it's as you get farther away, the wave the wave changes. And the directions just say compute the earthquake magnitude R for each set of values. So I'm looking at letter A. I'm just gonna plug 250 in for A. I'm gonna plug 2 in for T. I'm gonna plug 4.25 in for B. R equals log of 250 over 2 plus 4.25. You can just throw that all straight into your calculator. Log 250 divided by 2, and then plus 4.25. Enter, and we get R equals 6.34. We can just round it to 2 places. We'll do 6.35. I said 6.35 magnitude. That wasn't too bad, was it? Can you do the next one without me? Try it on your own. All right, and I got 5.38 for my next one. Let me know if you got something different. All right, questions, thoughts, comments on what you're doing? Okay. All right, that is technically the end of 3.4. We're gonna keep going on notes, but as it like we're in team timeout right now, and you have homework due on this next class, which is Monday. So your 3.4 homework is due on Monday. We will not finish 3.5, so you will not have to do that, but we are gonna start it enough, so maybe you'll get a little bit of a time to work on that, or you at least have the skills to work on that. Anybody have any questions before we jump into 3.5? All right, Alpha was really cruising with this. Number 1 says solve, no calculator. I want to get all of number 1 done. So once we solve all of number 1s, then we will be done for today. Okay, no calculator, so I'm getting rid of my calculator. Earlier in 3.3, we had logs where we were solving. Now we're solving these exponential. I think most of these we can keep in exponential form. We don't have to put them into log form, but we could if we needed to. We are going to solve these by getting them to get the same base on both sides. Then you can set the exponents equal to each other. So I'm looking at this one right here. I have 2 to the x equals 8. My question to me is, can I rewrite 8 as 2 to some power? 8 is 2 to what power? 3 to the third. So 2 to the x equals 2 to the third. Since I have 2 to the x equals 2 to the third, they both have base 2. You can think of those bases just canceling out, and the exponents must equal each other. In this case, I didn't have to solve anything. I just said x equals 3, and we called it a day. All right, keep going. Let's do the next one. If I have another number there, I gotta move it first. I'm gonna minus or divide by 3 on both sides. So I get 4 to the x equals 16. All right, you guys. Negative. Okay, yeah, kidding for a second. That's 16. All right, can you rewrite 16 as 4 to some power? Good, 4 to the second, good. Again, you can pretend like those bases, since the bases are the same, they're going to cancel out. So I'm going to be able to say x equals 2. All right, now, naturally that if we did 2 easy ones, I'd be like, oh, you try one on your own. But this one's a little bit different because I have 4 to the x equals 8. I cannot write 8 as 4 to some power. At least I can't easily. I can, though, make both of them go down to a base of 2. So 4 is 2 to what power? 2 squared, right? So I'm going to think of this as 2 squared to the x. And then 8's the same thing as 2 to the third. We just did that a minute ago. I'm a little dramatic by writing 2 to the second and then an x as that exponent on top of that. But at this point, this is where we can multiply those two together. That becomes 2 to the 2x equals 2 to the third. Remember, when your bases are the same, that's when you're allowed to get rid of them. So I'm allowed to do 2x equals 3. The 2's go away because they both have base 2, so you can just set the exponents equal to each other, divide by 2, x equals 3 halves.
Questions?
Bless you. Okay, keep going. Okay. Let me do 2 more with you, and then I can have you start trying some on your own. Or are you ready to start trying some on your own? You ready to go by yourself, or you still want me with you? Okay, no one's dying, so I'll stay with you for a little bit, okay? Let's get rid of that 3, divide by 3 on both sides. 4 raised to the 2x equals 32. This is one kind of like the one we just did. I cannot write 32 as 4 to some power, but I can write 4 as 2 to some power, and I can write 32 as 2 to some power. 4 is 2 squared, I know that. Does anyone know what 2 to what power is 32? The 5th? Okay, perfect. 2 to the 5th. Again, I was a little dramatic, but now I'm going to combine these. I'm going to do 2 times 2x, so it's going to be 2 raised to the 4x equals 2 raised to the 5th. And I have it in this form, so I can just set those exponents equal to each other. 4x equals 5, divide by 4, x equals 5 over 4. All right, one more together. Then I'm gonna let you guys fly free, little birdies. Do you hate that, Gavin? Did you wake up a little bit? Yeah. All right, divide by 2 from both sides. 5 raised to the x divided by 3. I know that's messy. It's divided by 3 equals 125. Oh, this one's actually easier than the last two because you can write 125 as 5 raised to some power, right? 5 to what power is 125? The third. Very good. I'm going to set those exponents equal to each other. X over 3 equals 3. This is where I'm going to multiply by 3 on both sides in order to get rid of that 3 in the denominator. So x is going to be equal to 9. I'm going to zoom out. We just did 5 together. I want you to try the next 2 together, then we'll go over it, and then we'll move on to the next side, okay? So I'm going to be quiet. You try the next 2 by yourself. Alright, I'm gonna start working on letter F. If you are done, watch me do it. If not, you can just keep moving and come back. I divided everything by 2. And then I wanna get everything written with the same base, and I think 3 is the easiest base. So I'm gonna do 3 squared, that's the same thing as 9. Keep that x plus 3 as my exponent, and then 3 to the third is 27. So I can think of that as 3 raised to the 2x plus 6 equals 3 to the third. And then now I want to set those equal to each other. So anybody have any questions before I set those exponents equal to each other? Okay, so I'm going to do 2x plus 6 equals 3 minus that 6, 2x equals -3, divide by 2, x equals -2 or 3/2. Okay, next one, same idea. I would know that you might be really tempted to make this a decimal. Please, please, please keep it a fraction. I've got 1/2 raised to the x over 4 equals 9 divided by 36. I can simplify to 1/4. And again, I know it's really easy to just like not leave it like that. I want you to leave it like that because I want to make that 1/4 be 1/2 to some power. 1/2 to what power is the same thing as 1/4? Squared. Very good, Quinn. Thank you. Once I realize that 1/4 is the same thing as 1/2 squared, I'm going to set those equal to each other. So I've got x over 4 equals 2. Just like the one above it, we are going to get rid of that 4 in the bottom, multiply by 4 on both sides, and I get x equals 8. Right, go ahead and flip your paper over. The next 2 are really similar to this. Go ahead and try those 2 as well. And then J and K look a little bit different. So go try the next 2. I'll follow up with you in 1 second. I'm going to start it with you, go a little bit quicker this time. That letter H on the board, I thought it was easier to get 1/3 and 9 to have a base of 3. So I made 1/3 be 3 to the -1st, and I made 9 be 3 squared. You are welcome to make 9 to have a base of 1/3. That would be 1/3 to the -2nd is the same thing as 9. For some reason, I didn't think that that would occur to you as quickly, so I thought the 3 was a little easier to do it that way. But you can do it either way; does not matter. Anybody questions on H? Okay, I'm going to start on I. Six. I actually think I was one of the easier ones. We kind of went from like hard, easy, easy, hard, kind of moving it around like that. So So check your eye, let me know if you have questions. These next 6 are pretty basic, but they are a slightly different lead up. So I wanted to make sure we did a couple together before I had you try some on your own. Are you guys ready for the last type of problem we're gonna do today? All right, the minute you saw that these had logs and none of the other ones that we've done today had logs, should have been a nice little tip off that we're doing a kind of change of direction, change of problem. We have done problems just like this before. Log base 7 of 49 equals x. Can you log roll that? Yeah, what would that be? Nope, log roll it for me.
So 7 to the x equals 49.
Good, 7 to the x equals 49. I'm gonna make us play it out because we're gonna do some harder ones in a second. So I wanna make sure that we can log roll. And then now what's my answer, Ava? 2. You can say 49 equals 7 squared, I don't care, but most of us at this point, we see pretty quickly that that's just gonna be x equals 2. That wasn't too bad, right? We've done that before. You're like, huh, I thought it was gonna be something new. Similar idea for the next one. What would my log roll for letter K be? 2 to the 3rd equals x, very good. And what is 2 to the 3rd? 8. Okay, cool. Like, oh, I thought that was gonna be harder. The next ones look a little bit harder, but the only reason is we're gonna have to do some extra algebra once we log roll, okay? So we're still gonna log roll on these other ones. If they don't have log by itself, you need to get a log alone before you do anything, but I'm just gonna log roll like we have been doing. When I do that, what am I gonna get once I log roll here? 4 to the 2nd equals x plus 2. I don't know why I did that. X plus 2. 4 to the 2nd is 16 equals x plus 2. How do I get x by itself?
Subtract.
Minus 2. X equals 14. Is are doing great. Now, one thing I do want you to check, I don't know if it will come up in this section or will come up later, but if I put this x back in, I need to make sure that I do not get a negative number. I cannot do log of a negative number, so that number in that parentheses must be positive. 14 plus 2, that's still positive though, right? So we're good there. We don't have to worry about it. I want us to be aware we might have to check it in the future. All right, we're gonna do the same idea for this next one. What's my log roll here?
2 squared.
Good, 3 squared equals 1 minus x. We can definitely log roll.
Oh, but they said you have one column.
Well, we haven't solved for x yet. The x has to be in such a way that this parentheses is positive. When I plug a number in for x, this is gonna have to be positive. So let's see what
So
number I get
lower
for
it
x.
to-
Yeah.
Yeah.
Okay, don't be confused.
Just do what we. did.
Just do what we've been doing. You good so far? Log roll's good. What's 3 squared? 9. 9 equals 1 minus x. Good, minus 1 from both sides, I get 8. And then, like Ava said, we've got this negative in front of the x. I've got to say x equals negative 8. Now, I know this is negative, so I know a bunch of you are like, well, you just told us it can't be negative. When you finish plugging it in, if it's negative, that's a problem. When I plug this in, 1 minus negative 8, what's that going to give me? 9. Can we do log of any positive number? Answer is yes. So even though this number is negative, it still works because I'm still plugging in and getting out a positive number. Okay? Okay, 2 more. Do you want to try them without me? Okay.
Someone's like, no.
Such like a 307 answer. Okay, let's get the log by itself. I'm going to divide by 2 first. Divide by everything by 2. I get log base 4 of x plus 1 equals 2. Nothing too crazy yet. Now, log roll. What do I get? Four squared equals x plus 1. It felt like I was hearing like letters and I was tripping. All right, 4 squared equals x plus 1. What is 4 squared? How do we get x by itself? Minus 1. 15 equals x. We doing okay? So I just divided everything by 2 and then I log rolled and solved like normal. We're gonna do the same thing for letter O. However, I have to move 2 things. How do I move that 6? Minus. -3 log base 6 of 4 plus x equals -6. Then what? Good, get rid of that -3 by dividing. So log base 6 of 4 plus x equals 2. Now we log roll. What happens when I log roll? Six squared equals 4 plus x. We're a little quiet on our log rolls. Are we okay? We're just mentally doing it, not saying it out loud. Okay, just got to confirm if we are struggling with that. 6 squared is 36. 36 equals 4 plus x minus that 4 from both sides. 32 equals x. All right, that is all I really wanted to get through today. Next class I see you, we're gonna do 3.5 together. Maybe I'll video alpha tomorrow, so then I have the video online a little bit longer if anyone needs to watch it. Ooh, that sounded bad. All right, we're done.